In this video, we are going to vibe code with Gemini 2.5 Pro model. My name is Steven. I publish regularly generative AI, machine learning, data science, tutorials, experiences, and so on. Please subscribe to my channel and enjoy the ride with me to learn generative AI and more. Before we start test the vibe coding with Gemini 2.5 Pro model, we need to have, first of all, Google account, and then we need to go to AI Studio of Google to get the API key. Then we need to have VS Code installed in our local machine, and we should also install the client extension for us to link the model to the agentic coding assistant. Without further ado, let's start testing. Okay, so first of all, let's create the API key, and we just copy the API key to the client interface. Please remember to choose Google Gemini as API provider. Of course, you can also choose others according to what you prefer. And for the model, I'm going to choose Gemini 2.5 Pro. So after setting this API provider, I think we are ready to go. Let's start with a simple project. Let's say code a Cyberpong game. And client is going to call the API of Gemini and start coding. And you can see the speed is very fast. So while the client is working with Gemini model, I want to share with you several experiences that I had. First of all, most of the tutorials you see in YouTube or in other social media, there are many simple examples. So those examples, I would like to say they are achievable by using Claude API or other models. So for example, if you want to code a snake game and so on, there's not much difference. As I'm showing you now, coding this Cyberpong game is not very difficult. And if you want to test the limit, you have to go one step further. For example, try something more complicated. So now we see the game has already been coded. So we see there are three main files: index.html, script.js file, style CSS file. And let's see the description. I have created the basic structure, styling, and logic. These are the three most important parts for this game at this moment. Let's run the command and see if we can play it. Okay, so here we are. Okay, so the control is basically by using the mouse to move the bar on the left hand side, and the program is using the bar on the right hand side. Yeah, I think it's quite okay, and you can see the styling and everything looks good. So let's close it and let's try another use case. Okay, now let's try something harder. I want a dynamic program to allow user to change parameters and see different state of cell movements. Let's see if it can create the program. So it is quite ambiguous, I know, but let's just see if the model can interpret it. Okay, so as you can see, now if my prompt is ambiguous, client will give you further question to let you clarify. So you can either choose the different option here, or you can just type your message here. I'm going to type what I need here: biological cell random walk. For the graphical display, I prefer 3D display. Let's say JavaScript. Okay, now let's see how it goes. Okay, because I already set the client extension to automatically read, edit, and run commands, so you are seeing that everything is run by the extension. If you prefer to have more control, you can change the parameters. Okay, now we choose yes and proceed. Okay, let's open the local. Okay, so now we have opened the program. As you can see, this is a 3D simulation. It's super elegant. You can see everything is inside this cube, and we can change different parameters on the upper left hand side. Let's try the number of cells. Yes, it is working okay. Let's increase the speed. Okay, looks pretty well. And you can see as you turn it around, the style actually changes. Actually, I think it fixes the light source. Yeah. So now let's see the boundary size. Let's try 5. Okay, smaller. Okay. Of course, you can also enlarge. It's pretty smooth. So if we reset the simulation, okay, everything starts from 0. Let's try another one. 10 cells, slower, boundary size 1. Very good. So I think this is okay for the 3D simulation. Okay, so I think this test is successful. Let's move to the next one. Now let's simulate another specific use case. Let's say simulate a internal management program for a bank to make payments to clients. The bank processes client request, formulate the info to SWIFT message style, and send out the message. Be sure that all procedural checkpoints are in place. Use simple but close to reality UI design. Okay, let's see how it goes. As you can see, until this moment, all the use case I test is at stage 1. Stage 1 is where you prototype, you formulate your program at a very initial state. Of course, you can add additional prompts to improve your program, but always pay attention. The complexity of the program will increase as you call the models again and again. This has been evidenced by many online posts and opinions from different experts. So you always need to pay attention to the debugging complexity and readability, interpretability, and so on. So please pay attention to this point. If you want just a one-shot simulation, a simple program, I think this model is very capable. If you want to iterate the program and improve its performance, UI, and so on, please pay attention to different details. It's like if we have 80% of the accuracy, we have 20% of the error. If we go further to the next prompt, the error or the misalignment will increase. Okay, now the program has finished. I think it also used a very simple framework, just to use HTML simulation. So it is following my instruction to make a simple simulation without incorporating more sophisticated modules. As you can see, it accurately states that the generation of a basic SWIFT MT103 message. So for those of you who are not very familiar with the banking system, MT103 is a very common message type to make client payments. Okay, so let's run the program and see how it goes. Okay, so there is an error. Let me see if I can open this program directly. Okay, I think we already have a good interface. So the first one is client request. Let's say sender account 123 123 123. I'm just using a very simplified example. DEUT 100 sender request. Okay, now we are seeing the procedure of the bank internal checkings. It goes through fund check. This is very good because whenever the bank is processing the request of payment from the client, it needs to check if its nostro account is with sufficient funding. And of course, we need to check with compliance part because anti-money laundering, counter-terrorist finance, and so on are mandatory compliance check for the banks. And then there is a beneficiary validation. Okay, so this is also important. And let's see, the last one is awaiting approval, ready for approval. Okay, approve payment. Yeah, and now we have a MT103 payment instruction. To really check the MT103 format, you can go to the SWIFT official website and check the menus. At this point, I think most of the information are clearly put here. So looks good, and we send out SWIFT message. Then we see there is a confirmation. Payment has been processed successfully. So from the UI point of view and from a simplified simulation point of view, I think it's quite impressive that Gemini 2.5 Pro has understood what I asked. So now let's test another use case. Okay, now let's test another use case. For this use case, I'm going to ask the model to create a 3 lessons machine learning course. Each lesson should have theory MD file, a Python file to simulate the algorithm, and a output folder with timestamp to store the simulated results, plots, etc. 3 lessons should cover 3 levels of machine learning. So I'm not going to create a comprehensive course like you can expand to 100 lessons or 50 lessons. That is too much for the model to handle. It is doable if you have enough API limits. But for me, I just stay in the free tier and let's see if it can complete the task. So as I said before, stage-wise coding, or we can say stage-wise vibe coding, should have usually a higher success rate. If you just input a lot of idea together, the results may not be very good. Okay, now it is creating the MD file and also the programming file. The first one is linear regression as the first lesson. Looks good. Now we are going to lesson 2, logistic regression. Okay, it also considers comparisons with other algorithms. Okay, looks good. Now we are going to lesson 3, k-means clustering. As you see, my prompt specified the structure of the program, like the directory structure, which files I want, and so on. So regarding vibe coding, if you have this initial structure, and for example, after 10 iterations, you keep on adding different lessons until 10 or 20, and suddenly you want to change the structure of the folder, you want to change the patterns of saving the results. Usually, according to my experience, there is a very high probability you are going to see errors. So this corresponds to what I said before. The complexity of vibe coding will increase after each iteration if you change multiple parameters or patterns. So you always need to pay attention if you want to build a program based on the initial project. Be careful about all the details to make sure that you can debug in the future state. Okay, now we have finished. Let's try to check them. First of all, linear regression. Okay, the description is quite simple. Of course, we can enhance later. And we have this program. Okay, and for lesson 2, we have also an empty file described the logistic regression. And we also have the program file. And also for lesson 3, we have the k-means clustering description and also program file. It's not perfect, but it actually follows my instruction because I did not say one part as supervised learning, the other part as non-supervised learning, but it gave me the classification like lesson 1 introduction with the linear regression is supervised learning, then classification with logistic regression is also supervised learning. Then the lesson 3 we go to unsupervised learning. So the naming of the lessons has a bit problem, but let's just ignore that for the moment. So just to run all of the programs, I have two ways. I can run it by myself, or I ask a client. I say run and test all. So let's see if we can generate all the results. Okay, first of all, it goes to upgrade all the necessary packages. And as you can see in the client interface, here is a button called Proceed while running. I would recommend you always to let the program to run, get the results, and then let it proceed by itself. Because sometimes if your program is running and you just proceed to the next API call, sometimes there will be some issues. Okay, so I would suggest to get the result first, let the client to make the next move, or you just manually intervene. So far so good. We see that there are many results printed. We also have this output folder, very well organized, with lesson 1, lesson 2, lesson 3, the folder name with timestamp on it, so we do not confuse it with other output results. Okay, now it has finished. So let's see, lesson 1, we have the linear regression. Okay, this is pretty good, because it does not say we use all the data to do the regression. It actually separated to training dataset and also testing dataset. Looks really good. And also we can see the results and different metrics to evaluate our linear regression result. Okay, for logistic regression, we have the confusion matrix. Looks good. The logistic regression boundary. And we also have the test data marked as yellow dots. Looks good. And we also have the results. And also the RC curve, let's see. Okay, looks good. Then for lesson 3, k-means clustering, we see the elbow chart. Of course, we can improve. For example, we need the line to indicate which is the best number for clustering. It is not present, but sometimes when I tried the web coding before, in some cases, the model can directly implement that strategy to show you the cut points of the number of clusters. Okay, now we can see this is the clustering results. Okay, looks good. And for the result part, we also have the txt file showing everything. Okay, so if you want to improve, you can add more lessons. You can also add a general MD file to describe the whole course. And of course, you can iterate for further improvements. Okay, so now let's try another use case where we ask the model to create a dynamic model hyperparameter tuning and testing interface of Fourier function simulation. Okay, this is a quite a general prompt. Let's see if the model can interpret it. So basically, I'm not limiting the Fourier simulation to any specific case, but yeah, it actually did not ask me further prompt. It goes to the simulation. Let's see. Okay, as usual, first of all, we have the HTML file and also the styling file. And let's see what's going to happen next. Unfortunately, I have reached the daily API call quota. Okay, if I retry, it will give me the same response, I think. Yeah. So in this case, you have two ways to resolve the issue. One is that you have another API key, you just apply it. Another way is to use OpenRouter. I already had my API key. And here you see you have the Gemini 2.5 Pro free version. Usually it works, but in OpenRouter, you also have a limit. Okay, so now I change to OpenRouter and retry and see if we can complete this program. Okay, so it continues to write the JS file. Good. I think we can complete this project before we run out of the tokens. Okay, it has finished the job. Now let's run command and see how it goes. Okay, there is a issue in my VS Code, so I'm going to open this file directly. Okay, let's see, run simulation and test. So base frequency, let's increase to 10. Amplitude 2. Number of Fourier terms, let's make it 10. Learning rate, regularization, okay. So the plot actually changes. I'm not sure if learning rate and regularization is making any contribution here. Okay, so let's try some extreme case. Let's see if the program can still handle my request. Okay, good. It is okay. I think it's quite clear that if we change these parameters, the first three parameters, we can have different Fourier simulation plot. I would call it okay, not perfect. We have finished all the tests for the use cases I just mentioned. Please leave a comment and let me know which project do you prefer. Which one do you think the Gemini 2.5 Pro model has achieved with the best quality? I'm going to publish all the code in my GitHub, so if you want to review them, feel free to check them out. Please remember, there are pros and cons always regarding the large language model. The key issue regarding vibe coding would always relate to inaccuracy, difficulty of debugging, and the complexity of the program, etc. And there are also some convenient parts about using vibe coding. For example, you can quickly prototype any program you want. You can also speed up your learning experience. So now you do not need to wait too long before you see some simulations and get some intuitions to help you learn different subjects, especially about coding. But it can also be expanded to mathematics, physics, and different subjects. Please subscribe to my channel to keep up with additional contents published in the future dates. Leave a comment, share with your friends. If you like my video, give it a like. I wish you enjoy it. If you want to see different tutorials, different tests in my future videos, please leave a comment. I wish you enjoy it and see you next time. Bye bye.